The crystal is a thin slice of piezoelectric material. So piezoelectric effect is any mechanical vibration which is produced or imbibed on the crystal. It will convert that into electrical charge, or it will convert mechanical into electrical voltage. In the reverse piezoelectric effect, if you apply electric field, you produce mechanical strain. So you have piezoelectric effect and reverse piezoelectric effect, but here we are going to use piezoelectric effect only. So when the crystal is impinged with mechanical stress or any vibration relating to the molecules, it is going to produce an equivalent electrical charge in the form of voltage as output from the crystal. So you have three crystals, quartz, tourmaline, and rochelle salt, which are exhibiting piezoelectric effect. But we find that the crystal oscillators made of quartz, they are found to be stable, and they are having this property of producing electrical voltages. So where this crystal oscillator is used, so in applications where high degree of frequency stability is required, even if I use this crystal oscillator for 10 to 15 years, my frequency of oscillation F naught should not change. So in those applications, I'm going to go for crystal oscillators. So generally, crystal is a ground wafer of quartz or tourmaline, which is placed between two metal plates. So I'm going to place the crystal between two metal plates. So different ways of cutting the crystal are there. You can see this is your quartz crystal. It is a hexagonal, double hexagonal, bipyramidal structure. So you can see two hexagons, and above that you see a beautiful pyramid. So it is a double hexagonal pyramidal structure, and there are many methods of cutting your crystal. X cut is I'm going to make a cut along the x-axis, and Y cut is I'm going to make a cut which is going to be parallel to the electrical axis or perpendicular to the mechanical axis. So see here how we are going to cut the crystal, whether it is going to be X cut or Y cut will determine the frequency of oscillation from your circuit. So if I'm going to use an X cut crystal, I'm going to cut perpendicular to electrical axis. If I'm going to use a Y cut crystal, I'm going to cut perpendicular to my mechanical axis. So two types of cutting the crystal are available, and depending on what cut you make along the X or along the Y direction, correspondingly the frequency of oscillation and all other parameters are going to vary. So if we are going to apply an AC voltage, then the crystal is set into vibration. So how much it is vibrating, the frequency of vibration is equal to the resonant frequency of the crystal. So when you apply an AC voltage to the crystal, it starts vibrating. All the molecules in the crystal are set into vibration. So how much the crystal is vibrating will determine the resonant frequency of the crystal. Okay, that is a very interesting property of the crystal